Hey guys, here's your solution video to the practice Newton's second worksheet. Practicing with Newton's second law. So to start, I'm going to write two equations up at the top. We have the sum of the forces equals mass times acceleration. I'm also going to write my force due to gravity equals mass times the gravitational field strength. The acceleration due to gravity, as we can call it now. To start each of these problems, the first step is to identify the mass. By identifying the mass, we can then do the sum of the forces. To identify mass, if it's not directly given in the problem, you will use the force due to gravity equation. Then we'll be able to use the sum of the forces. So in this first one, we have a 1 kilogram book at rest on a tabletop. So drawing the force diagram, every single one of these will have a force due to gravity. Now we are at rest on the tabletop. So if we're on a tabletop, we'll have a normal force. We know the mass is 1 kilogram. And we know that we're at rest. So since we're at rest, we know that we're at a constant velocity. The forces are balanced. So the net force in x is 0 because we don't have any, which means the acceleration is 0. The y's will also be 0 because we're at rest. So number 2, a 5 kilogram flying squirrel flying from a tree to the ground at a constant velocity. So now we want air resistance. So if we have air resistance, that means that we have the force due to gravity pulling him down, and then we will have air resistance working on him because we're considering that. There again, no forces in the x direction, which means there's no acceleration in the x direction. We're at a constant velocity. Whenever you see constant velocity, we will know that the sum of the forces will be 0. So the acceleration will be 0 also in y. Number 3, an egg with a weight of 0.1 newtons. So that weight is your force due to gravity. So that will equal 0.1 newtons. And we're neglecting air resistance. So again, no forces in the x direction. I mean, there's no acceleration in the x direction. Now we have to look at the sum of the forces in y. So here we just have one force acting in y. It's that force due to gravity. It's going down, so it'll be negative 0.1 newtons. So now in order to find that acceleration, we need the sum of the forces equals mass times acceleration. So to find the mass, again, remember we have to use that force due to gravity. So we would take force due to gravity equals mass times the acceleration due to gravity. So we will have 0.1 newtons equals our mass times, and that's negative times negative 10 newtons per kilogram. When we divide negative 10 over, we'll get a mass of 0.01 kilograms. So with that being our mass, we can now plug it into F equals ma, Newton's second law. And hopefully, as we'll find out here, we know the force. Now we know the mass. What's the acceleration? Well, it's the equation that we just did. because we just have the force due to gravity, the acceleration will then be the acceleration due to gravity, which is negative 10 meters per second per second. Number 4, we have a 2 kilogram bucket tied to a rope and is accelerating out of the well at a rate of 1.5 meters per second per second. We're neglecting air resistance. So our force diagram, we'll have our force due to gravity, and then we'll have tension. So as we see again, there's no forces in the x direction, there's no acceleration in x. We want to find the weight of the object. So we want our force due to gravity is 2 kilograms times negative 10 newtons per kilogram. So the weight of this object, the force due to gravity, is negative 20 newtons. So we have negative 20 newtons. But now we're given the acceleration. So we know that our acceleration y is 1.5 meters per second per second. Knowing that information, we can then find what the sum of the forces is in y. So the sum of our forces in y equal the mass of the object, is 2 kilograms, times 1.5 meters per second per second. And when we do that, we see that the sum of the forces in y equals 3 newtons. And this means that because it's positive, we have that upward acceleration at 1.5 meters per second per second. So if our force due to gravity is negative 20 newtons, that means that the tension, the force of tension in the rope, must be 23 newtons. We know that because the sum of the forces in y is 3. So that means that 3 newtons equals the up force plus the down force. So if the down force is negative 20, that means that we need a tension force of 23 newtons to have positive 3. So now we're going to draw. So we got a 2 Newton force is applied to a 1 kilogram block in order to move it across a desk with an acceleration of 0.5 meters per second squared. Consider friction, neglect air resistance. So you'll have our force due to gravity. We're on a table, or on a desk, so we'll have a normal force. And the sum of our forces in y, because we are accelerating in the x direction. We're not accelerating in y anymore. So the sum of forces in y will be 0, which means that the acceleration will be 0. So this one doesn't give a direction with which we're applying the force. So I'll have the applied force going to the right. We're considering friction. So we'll draw friction pulling back on it. So we have an acceleration in x, and it is accelerating what I have considered to be the right. So my acceleration here is positive 0.5 meters per second per second. And if we know that the applied force is 2 newtons, so we have the applied force is 2 newtons here on a 1 kilogram book. So we're going to have the sum of the forces in x will equal 1 kilogram times 0.5 meters per second per second. So multiply 1 by a half. We'll get the sum of our forces in X will equal 0.5 newtons. So if the sum of the forces in X is 0.5, and we know that the force to the right is 2 newtons, by using this sum, where this 0.5 equal the forces to the right plus the forces to the left. If we know that our force to the right is 2 newtons, that means that our force to the left has to be negative 1.5 newtons. And actually, I did just solve for the net force. Where the net force is 0.5. Number 6, 1.5 newtons applied to move it across a desk at a constant velocity. So here we're going to have our applied force, normal force, force due to gravity, and we are considering friction. But we're moving at a constant velocity. Constant velocity means that our forces are balanced. So when our forces are balanced, the sum of them is 0 in each direction, which means that we have no acceleration. "70-kilogram skydiver" is the next one. Moving with a constant velocity. So as he's falling, it's force due to gravity, and then he has his normal force. Or not normal, I'm sorry. He has air resistance. He has air resistance. No forces in Y. It means that his acceleration in X is 0. He's again descending at a constant velocity, which means that his forces are balanced and his acceleration is 0. So our next one, 30 Newton force, is being applied to drag a sled with an acceleration of 1 meter per second per second. So the snow, that surface, will have a normal force, and then we are applying a force, and then we're going to have the friction of the snow. Because he's not accelerating in the Y direction, the sum of the forces are 0, so that acceleration becomes 0. So now we have 30 newtons pulling 20 kilograms with an acceleration of 1 meter per second. So if we use Newton's second law, force equals mass times acceleration. We have 20 kilogram mass at 1 meter per second. So this means that the sum of the forces in X, so means that F sub X is 20 newtons. So the sum of his forces is 20 newtons, because we are accelerating at 1 meter per second squared. And the last one, we have, again, force due to gravity, normal force. It's coasting to the right with a leftward acceleration, so friction to the left. So the sum of forces in Y is 0, acceleration is 0. 8. So now we need our sum of the forces. So we have our forces in Y equals mass times acceleration. 800 kilograms times 1 meter per second squared will get us 800 newtons and it's to the left, so it's negative.